Linear programming, 5 videos are there. Okay, that is 10 minutes videos with questions I will make. That will be more than enough. I hope you might have understood that part. So you'll be doing that part. Let's start the work better because you people are waiting, so only I started. Otherwise, Joshika revision, we are going to start from the beginning. Ready, everyone? So now look here, give a heading probability. So first we are going to understand what is the meaning of probability. Probability is nothing but possibilities. So possibilities can be of many types, where possibilities of particular event introductions will be there. So whenever somebody will talk about probability sections, we need to understand few important definitions first. Okay, so we'll start the definition sections in probability. The first important section in probability definition parameter. Let's start this. Just 1 minute. Hold. So if anybody will be asking you about probability, means what you are going to say. Probability is nothing but occurrence of an event from a well-designed number of events. So we will start from the beginning section. First, we will learn some of the trend of writing probability. So one is word is called as random experiment. Just I'll write the name and I will exactly explain what is called as random experiment, what is called as elementary event. So random experiment is what? If somebody will ask you what is the meaning of random experiment, so one by one I'll explain what is the meaning of random experiment. So if somebody is writing about RANDOM, random experiment. Okay. So what is random experiment? Random experiment, Ms. Kaushikaranjini, good evening, beta. So if an experiment when repeated under identical situations, understood? If an experiment when repeated under identical situations or conditions do not produce the same outcome, it is considered as random. Correct now? So this will be considered as what, beta? Random. So but the total outcome of this trial on a several outcome we are going to check. Okay. So just write down in an experiment when repeated under identical conditions, in an experiment, when repeated under identical conditions, when repeated under identical conditions means I took a dice and I am throwing the dice. So when repeated under identical conditions, do not produce do not produce the same outcome every time. Do not produce the same outcome every time. Do not produce the same outcome every time, but the outcome in a trial, but the outcome in a trial, but the outcome in a trial is one of the several possible, is one of the several possible outcomes, is one of the several possible outcomes, then it is considered as random experiment. It is considered as random experiment. Now we will understand random experiment in simple example. Understood? So this will be coming under random experiment. How we will be exactly talking about random experiment, beta? So now we are going to throw a dice. Understood? So when we are throwing a dice, we cannot get a head or tail now. No. So when we are throwing a dice, so total how many possibilities are there? Sample space. Sample space is total number of outcomes. What can be the total number of outcomes? Either 1, 2, 3, 4, 5 and 6. So that means a dice will be having how many faces? 6 faces. So all the numbers will be written on the face. 1, 2, 3, 4, 5 and 6. Understood? So in all the faces numbers will be written. In all the faces what will be written? Numbers will be written. So out of this number, when you will do one experiment, one time you threw the dice, you are getting 1. One time you threw the dice, you are getting 2. One time you are throwing the dice, you are getting 5. One time you are throwing the dice, you are getting 6. But it will repeat, but it will not change the number. Out of 6 possibility, only 6 numbers can come. You cannot expect 20 from the dice. Why? Because 20 is not there. Understood? So whatever is there in the sample space, whatever is there in the part of experiment, that number will only come. Good evening, Sanjana. So only it is called as what? Random experiment. So only what it is considered as beta? Random experiment. Come, experiment. Understand probability very thoroughly better. So if somebody will ask you about probability, what answer you are going to say? So first we are going to understand what is the meaning of random experiment. Understood? Got it? So randomly we are doing in English what we are loga. Good evening, beta. So in English, what word we are using? Random. Okay, I am randomly selecting a person for my party. Randomly selecting means I am not so synchronized. I am just selecting is coming from 52 cards only. That card is coming from where? 52 cards only. That is considered as random selection. That is considered as what beta? Random experiment. So this is the most important part. I hope you might have understood. So this is a part of what beta? Random selection. Now we are going to call it as elementary event. So what is the meaning of elementary event? So random experiment understood now? If I will take a coin and I will throw the coin, how many possibilities are there? Two. What are they? Either a head or a tail. Can we expect 100 rupees from there? No. So that means what? That is called as random experiment. But beta, every throw you will get head. It is not necessary. In some throw you can get head, or in some throw you can get tail. So understand probability as a beginner point of view from zero level. Understood? So this is considered as what? Sample space. Sample space means selection of all the event is called as sample space. What is sample space? Total events of the experiment will become the sample space. Now, beta, you have dice. You have what? You have dice. Now, dice is having how many faces, beta? 6 faces. So, how many possibilities are there? 6. So, sample space will become 6. I hope everybody understood. Sample space will become here 6. Understood or not? Now, from there, any specific, like Shakti, I am asking you, can you throw a dice and the dice can give you 5? Dice can give you 5. Then that is called as elementary event. When specifically I will ask you one specific outcome, it will become elementary event. Are you understanding? What is the meaning of random and what is the meaning of elementary? Elementary means shortlisted one. Got it? So if I will say that ki sample space is having 6 outcomes, and from there give prime numbers. Give what numbers? Prime numbers. So beta, how many prime numbers are there? 2, 3, 5. So these are elementary event. Prime numbers will become the elementary event there. So till here logics you understood now. What is the meaning of random? Random means like that only. Understood? What is the meaning of event? Elementary event? The event which are exactly chosen, which are exactly selected for bringing the answer, it is called as what? Elementary event. Now next is event. So the set of all possible outcomes. So now elementary event will become all possible outcomes. All possible outcome set will become what? Elementary event. Now write down about elementary event. Event you understood now? I will specifically ask you, give me a prime number. That will become the event. So now what is the meaning of elementary event? Note down. So elementary event in a random experiment, in a random experiment, each outcome is known as elementary event. So each outcome will be considered as elementary event. So random experiment, each outcome will be exactly considered as what? Elementary event. It will be considered as what? Elementary event. Each outcome will be considered as what? Elementary event. I hope you might have understood. So now we will go for the next one. Event you understood now? Sample space you understood? Total outcome will be considered as sample space. Event means a specific one. If I give you prime number means you have to select prime number and give. So this is elementary 2, 3, 2, 3 and 5. Together event is coming and we are getting the answer. I'm fine, thank you, Ajay. So now we are going to talk about sure event, impossible event. So now specific small thing about probability I am discussing. Now, beta, the next part is occurrence of an event. When can an event be occurred? If somebody will ask you this question, when can an event be occurred? So at the time of any type of experiment or observation, if you are doing that experiment or if you are doing that observation, that time only you can the event can come. So that's why it is called as occurrence of an event. Understood? So if I am having a dice in my hand, that means I will do experiment. Then what will come? Observation. Correct now? So if I don't have dice in my hand and I am telling that I am doing experiment, is it possible? No, because in my mind I will throw the dice and I can say any number. That's a different thing now. But practically I'm having a dice and I'm throwing. That means I can expect outcomes. I can expect what beta? Outcome. So that's a very important thing. So occurrence of an event means in a random experiment, if any event is coming, it is considered as what beta? Occurrence of an event. Now, beta, event can be two types. One is called as sure event and one is called as impossible event. One is called as sure event and one is called as impossible event. Understood? Sure event and another one is called as impossible event. So what is the meaning of sure event? When the surety is 100% high means it will occur, it is considered as sure event. But if it is not there, it will become what? Impossible. How? Now let's check this one out. Now beta, if I am tossing a coin, what is the possibility of getting head and tail both? Both? Then it is a sure event. No? It is a sure event. Means what I am searching? Head and tail. And what I will get? Head and tail. So it's a sure event. Sure event is 100% possibility of that event. So if somebody said that, what is the event of getting head and tail when you throw a coin? Then what is the possibility? One head and tail is there. So what is the sample space? Sample space is also head and tail. So what is the number of element in event? 2. What is the number of elements in sample space? 2. What is the probability of having this event? 2 by 1. So this is called as, one is coming, this is called as sure event. Sure event will be exactly coming as 1. Sure event will be coming as what beta? 1. But if somebody will tell, find a probability of getting a number 6 when you are throwing a coin. Is it possible? Will you be able to get a number 6 when you are tossing a coin? Is it possible? No. So that is considered as impossible. So that time the event will be empty. Got it? So event will become 0. So probability of getting that event is coming 0 by head and tail is sample space. So 2. Answer is coming. So coin will have head and tail. So it will have sample space as number of elements in sample space is 2. So answer is 0. So probability. What is the maximum value of a probability? The maximum part is coming as 1. So probability of occurrence of an event lies between 0 and 1. Where this one is impossible. and this one is considered as sure. Impossible means which cannot come is considered as impossible, and which is 100% to come is called as sure. Understood? So, like one coin I tossed. So, beta, when one coin I am tossing, hey, note down this one. When one coin I am tossing, how many possibilities will have? Two. What are they, beta? Head or tail. So if somebody like I ask from Shakti, what is the possibility of getting a head or tail? He will say that ma'am, I can get head also and tail also. So event is head and tail. And then sample space is also two. If I am cancelling, it is coming as one. Correct? So it is exactly coming as probable. So this is called a sure event. Sure event will always be considered as 1. Impossible event will always be considered as 0. Where the possibility of getting an event itself is not there. Like I am tossing a coin and I am telling bring me number 6. Is it possible? No. So that becomes impossible. So what is the what is the probability? So probability value lies between minimum and maximum. What is the minimum value? 0. What is the maximum value? 1. So minimum 0 is considered as impossible and maximum 1 is considered as sure. Shall we go for the next one, Peter? The next one is called as mutually exclusive event. Note down. This one does not mean sure and impossible. So, Peter, probability values lies between what, Peter? The event of probability lies between maximum it is going as 1 and minimum it is going as 0. The values of probability will never be negative. Probability answer will never be negative. Probability answer will never exceed 1. Understood? Maximum value is 1. Minimum value is 0. You remember, negative will never come. Fractions will come, but it will never be exceeding 1. It will never be exceeding 1. So that you need to remember here. So now we can write that in mutually exclusive event. Write down. The next one is mutually exclusive event. Now write down what is the meaning of mutually exclusive event. When two or more events associated with a random experiment, when two or more events associated with a random experiment are said to be mutually exclusive or impossible, if the occurrence of any one of them, if the occurrence of any one of them occurrence of any one of them prevent the prevent the occurrence of all other. Okay, this is called as mutually exclusive. What it is considered as beta? Mutually exclusive. So let's understand what is the meaning of mutually exclusive. For mutually exclusive, one single part you will do, and that is their intersection will be always phi. Mutually exclusive means intersection part will always be phi. This is considered as mutually exclusive. Like A intersection B will become equal to 5. Then common part will not be there. Understood? So they don't have nothing common. That is called as mutually exclusive. We'll start with conditional probability because mutually exclusive understood na beta? So this is called as mutually exclusive. Understood? So we can see mutually exclusive number. So this part will be there like see probability of occurrence of P of A union B is equal to P of A plus P of B minus PA intersection B. So for mutually exclusive, P of A intersection B will become equal to 0. P of A intersection B will become equal to beta, I am writing here. Can you be able to see P of A intersection B will become equal to 0. It is equally equal to 0. So that means what is the final outcome beta? A union B is equal to P of A plus P of B. This is the situation of mutually exclusive beta. I am unable to read out beta what you have written. So now look here. This is exactly considered as what? P of A plus P of B. Note down beta. This is considered as P of A plus P of B. This is called as mutually exclusive event. Understood? Huh? So this is considered as mutually exclusive event. Now, if somebody will be asking you, yes, if somebody will be asking you what is the meaning of exhaustive, Shakti written from probability section written 2-3 questions are coming. We will be our target is collecting probability. Understood? See, once probability is done means again we are starting from the zero level. Now probability itself is zero level I am starting. Small things I am explaining so that it will not going to create problem for you. So now beta, what is the meaning of exhaustive event? Write down EXHAUSTIVE, exhaustive event. Exhaustive. EXHAUSTIVE, exhaustive event. Exhaustive event. Now, beta, how we are going to talk about exhaustive event? Means random experiments are there, na? Sure. So, what is the meaning of random experiments? Probability of occurrence of A, probability union, probability of occurrence of B, probability of occurrence of C will become sample space itself. Understood? So we will direct write probability section. We'll write probability means A union, B union, C union D will be equal to sample space itself. Understood? One kuti event joined together and will give you the sample space. Will give you the sample space. Like probability of getting a head. Probability of getting a head and union probability of getting a tail will give sample space itself. Then it is called as exhaustive event. What is considered as exhaustive event? Till here it is clear, beta? Now, without wasting time, there are certain words that you are going to use for writing. Understood? So that words I want you to understand and I want you to note down. Till here it is clear now, beta? What is random experiment? Taken from one experiment we are taking. That is considered as random. Event means when I will ask you. that this event you have to be. Then after that, what is there? But impossible means zero. Sure means one. Sure means one. Impossible is zero. And then probability values lie between 0 to 1. Got it? Now, because there are certain equations and certain terms we must use. Now, look at it. One is probability of occurrence of an event plus probability of non-occurrence of an event is always equal to 1. Understood? This is that formula which is very very important. Probability of occurrence of an event and probability of non-occurrence of an event will always be equal to 1. That's the most important thing. So probability of occurrence of an event plus probability of non-occurrence of an event is considered as beta. Got it? It will always be considered as 1. Beta understood now? So now we will go for the next one. So if somebody will ask you the next part, we will first understand what is the meaning not A. This meaning is not A. Understood? This meaning is considered as not A. So if this is A, this is not A. And the probability of getting A plus probability of not getting A is equal to 1. Got it? So now we will learn some of the terms, some of the parts. The first part is not A will always be represented as A bar. Understood? Second term is A or B. When you heard this word A or B, it is written as A union B. If you will see A and B, and means intersection. Here it is exactly total we have to take, and this is exactly common part only we are taking. Understood? Total and common part we are taking. Next, A but not B. A but not. At that particular moment, A but not B. A intersection B complement. This is A but not B. Understood? B but not A. B but not A. Neither A nor B. Both complement section. Neither A nor B will be coming as both complement. Note down please. Neither A nor B will always be coming as. Kartika, good evening, beta. Physics class is over. Yes, Kishore. Just writing that scene. Okay, we'll do one thing, Navita, that previous partner little bit introduction to probability I have given. That introduction you can see afterwards. Just write all this parts. So not A means A bar. A or B means A union B. A and B means A intersection B. A but not B. A will be there but B will have bar. B but not A means B will be there but A will have bar. Neither of A or nor B. So A bar intersection B bar. So this is most important things. So now we will be, yes. Okay, beta. Well, can continue with this sections. Please kindly join and learn probability. Conditional probability today I am going to teach beta. That's a very important part. So most important sections and how to catch the questions in conditional probability. First I will teach you that only. Okay. So now beta, at least one of A, B or C. So next part they will say that at least one of A, B or C. How to write at least one of A, B or C? When they will be asking means at least C. If I will say that at least I can eat one chocolate, means that is my minimum part. Maximum chocolate, how much I can eat? I can eat maximum of any amount of chocolate. Na? At least means minimum I have to start. Understood? So here when minimum I have to start means it will become A union B union C. This maximum I will reach to the entire slot. Maximum I will reach to the entire slot. Minimum is what beta? Minimum is I can start with A only. That is called as at least one of A, B or C. Minimum is either I can take one or maximum is all three we can take. So this is called as minimum at least one of. Now exactly, if somebody will use this word exactly. Now what is the difference beta? If they will say exactly, at the time exactly one of A and B. So if somebody will use this word, exactly one of A and B, exactly one of A and B means कि when A will be there, B will not be there. When B will be there, A will not be there. This is considered as exactly one of A and B. This is considered as what beta? See, A but not B is single. But exactly one of A and B means one time you have to take A but not B. Ulta also you have to take na B but not A. They both will be there. Exactly one of means when you are there, I am not there. When I am there, you are not there. Both I have to take. But if I will say A but not B means only one possibility there. But if I will say exactly one of A and B, that I have to show both the possibility. That means when you are there, I am not there. When I am there, you are not there. But if word is, okay, I am not there, means you are there, fixed. You are not there, means I am there, that is fixed. But exactly one of me and you means this situation where both should be joined together. Both should be joined together. So this is one of the most important point to be noted here. Okay. So this is called as exactly one of A and B. When they will say all three A, B, C. That means there is no other thing, no compromise. It will become A intersection B intersection C. It means all three we have to take. It is considered as what beta? A intersection B intersection C. This is considered as all three. I hope you might have understood. This is called as all three. Now, beta, when we are writing probability of occurrence of an event, now if they will say exactly one of A, exactly one of A, B, and C. How we are going to write? Exactly one of A, B, and C. Exactly one of A, B, and C. Exactly one of A, B or C. Now look here. If you will be doing this part, exactly one of means one means A will be there, B and C will not be there. Done. Exactly one means only one will be there. Now union A will not be there, B will be there, C will not be there. Now A will not be there, B will not be there, C will be there. This is called as exactly one of A, B or C. But if exactly two of A, B and C is given, exactly two of A, B and C. Exactly two of A, B and C when they will ask. So A and B will be there, but C will not be there. B will not be there. A will not be there. So this is called as exactly two of A, B and C. So these are certain rules and now we will go for our specific work. Understood? Our specific work is first we need to understand what is the meaning of addition theorem and how in probability we are writing addition theorem. Understood. So in addition theorem, what all things are there, we need to understand. Addition theorem. So I'm starting with addition theorem. Down. Sitting and standing is not at all easy for me. So now beta addition theorem, we will write addition theorem. The questions based on addition theorem also we will do. Remember the part, whatever I am telling you, do it. Trust me and do it. After that, we will see. Okay. So now first part of addition theorem is, beta how addition theorem is written? Probability of A union B is equal to probability of A plus probability of B minus P of A intersection B. This is considered as addition theorem. This is condition theorem. Understood? This is considered as what? Addition theorem. Got it? So now for mutually exclusive, for mutually exclusive means nothing common. A intersection B will become equal to 5. So that time probability is coming as probability of occurrence of an event is P of A plus P of B. This part will not be there. This is for mutually exclusive and this is for addition theorem together. Okay. So this is the case. Please note down. Hi Smriti. So this is the case we are going to note down. See how we are getting probability first to understand. So when somebody will be asking you how to write probability, first you learn how to write probability. Probability, how we are finding. So now how we are writing probability, madam? So we are writing probability as if P of A means number of NE by NS. So NA by NS. A is the event now. So A is the event by NS. So this is called as P of A. So for finding probability, first we have to find NA by NS and then only probability will come. Got it? So this is called as probability of event, what you are exactly getting. Understood now? Note down this one. I hope you might have understood here, beta. Hi Smriti, after so long I'm seeing you now. So now look at it. We'll go for the next one. Are you ready for it? So addition theorem is this one. What is that? Addition theorem. But beta, more than addition theorem, we are going to conditional probability because the part from where the question that is exactly coming under conditional probability. Shall we discuss one of additional theorem? Okay. This is exactly considered as additional theorem. Now we will go for conditional probability. So when somebody will be asking you what is the meaning of conditional probability, we will be learning conditional probability. Let's check this one out. Conditional probability, note down. Conditional probability is P of A by B. Means occurrence of an event when second one already occurred is coming under conditional probability. Just note down. Let A and B be two events. Write down. Let A and B be two events. Okay. So how many events are there? Let A and B be two events. I can't stand. Okay. So let A and B be two events associated with a random experiment. I have explained what is the meaning of random experiment. When A and B be two events associated with a random experiment, then probability of occurrence of an event A, then of an event A, then probability of occurrence of an event A under the condition under the condition that B has already occurred under the condition that B has already occurred and probability of B must never be zero. That must be the most important thing. So B has already occurred. It is called as conditional probability. It is condition. It is called as. It is called as. Then it is called as conditional probability. This is condition at. It is considered as what? Conditional probability. Now, how we are writing conditional probability? So conditional probability will always be written as P of A by B. That means what beta? Probability of how we are reading it as pedagogy. Probability of occurrence of an event when B has already occurred. Probability of occurrence of an event when B has already occurred. We speak like this beta. How we are saying probability of occurrence of an event when B has already occurred. When B has already occurred. Probability of occurrence of an event when B has already occurred is called this one. Probability of occurrence of an event when A has already occurred. Note down. Probability of occurrence of an event when A has already occurred. This is called as occurrence. So B has already occurred means A by B. B has A has already occurred is B by A. Understood? Means one event has already done, second is going to happen. So this is A by B and B by A. Please note down. Then first we will solve some NCRT questions. Understood. So occurrence of an event when A has already occurred and B has already occurred. Now, how we are going to write? Formula is the formula for this I am writing conditional probability formula. Note on please. So, when probability of occurrence of an event B, when B has already occurred, how we are writing beta? N of A intersection B by N of B, because B has already occurred. Okay. So now probability of A. I hope you might have understood better. So this is for occurrence of B and this is for occurrence of A. Now write next one. A is equal to 135. B is equal to 23. Now find beta P of A by B. First we will find A intersection B. What we will find? We need to find this one and this one. So when you are doing A intersection B, what is A intersection B beta? What is common? 3 common. So number of element in A intersection B is only one. Got it? So number of element in A is 3. Number of element in B is 2. Number of element in C is 4. Done? So now how we have to solve? First for solving this one, P of A by B, it will be N A intersection B by B down now, so NB. So it will become 1 by NB is how much better? Easy? Easy one? Check this one out. Note down. Understood? B by A means beta. Do it. This is 1 and N of A is 3. So 1 by 3. Tough or easy, yeah? Easy, na? Just intersection. Is it done? Now, beta, if they will ask you this, how to do this? In this next section, question is NCRT question. Do this question. See, I'm doing little bit slowly. P of A union B by C. Now you find. Did you note it, beta? Slowly, slowly, I'm writing. Please write down P of A union B by C. Now look at beta. Now look at beta A union B. So how we are going to find N of A union B intersection C by NC. This is the formula, na? Because first we have to find A intersection B. So A union B will be what beta? First we will find A union B. This one written, na? So A union B, how to find beta? A union B is equal to 1, 2, 3, 5, 4. N of C is 4. Correct, na? N of C is 4. But beta, intersection C. C part is what? 2, 3, 4, 5. So what is N of A union B? First point we will do A union B intersection C. Do what is common beta? 2, 3, 5. 2, 3 and 5. 2, 3 and 5. So what is number of element in A union B intersection C? 3. So probability of A union B by C will be N of, note down nicely, N of A union B intersection C by N of C. So it is coming as 3 by, C is having how many elements beta? So answer will come 3 by 4. Note down. I hope you might have understood. Yes, with the probability only. Just now I'm going to finish it up because conditional probability, this part I have discussed. I can't stand more. Tomorrow, 4 hour class I plan to take for you people. In that first short revision I'm going to do, and I'm going to keep the students in one single group where material transfer will become easy. So slowly we will be transferring material for practice, for maths, and then conducting test. That has to be done because after probability, three videos of LPP means it is over. Okay, so I'm keeping it really a bit. Probability, yes, I started probability. If you see means conditional probability section I have discussed before. Hello Jia, I can't see, I was sitting and doing.